Yo, what up, internet? I know, I might look like a lazy guy, but I've actually been working on some projects on the side, and I've been working on this RTS. And I found that making a single select system is actually really simple, but making a box select system that accurately represents what you're selecting is a little bit more complicated than it may seem. So here's what I'm talking about. You have this box on the UI that you drag, and it actually one for one translates the rotation and scale of the points on the ground to select the exact units that you want to highlight. The way this works is actually a little more complicated than it may seem. You'd think that you just have to get the four corners of the box, screen point array, and draw an overlap box in that. But with that, we're not accounting for rotation. So throughout this tutorial, we're going to create a system that draws a box on the screen, raycasts from those points, and gets the rotation on the ground in world space so we can get all the units that we want to get selected. I'm going to break this tutorial into little segments so you can start and stop whenever you want, come back to where you were. It'll be a lot easier. Before we start, I wanted to thank my patrons, Richard Gamble and Jerry He. It means a lot to support me, even though I'm a small creator. Thank you so much. So all these assets are available on my GitHub. I created them. You can use them in anything you want. And it's also a good place to start. So let's go in the starter project on my GitHub, which is the link in the description. Make sure to leave a like if you like this video, if you like this kind of content, subscribe if you want to see more of it, and leave a comment. Tell me if you like this style of tutorial, if you want something else, just drop it in the comment. And with that, we're going to go in and create an interface. So I guess to start out here, we have our little scene. Just right now, it's just a man who can't really be selected. He runs around. He has a nav mesh agent on him, and he runs with a right click. We can get him to go where we want him to go. Very simple, very straightforward. So in order to start with this whole selection thing, I like to use an interface. So we're going to create an iSelectable interface. So let's go to our scripts. Let's create a folder. We'll call it interfaces. And let's create a new C# script called iSelectable. And if you don't know interfaces, I'm not going to go ham on it, but it's basically an addition you can have to your classes that enforces a certain kind of rule and also allows you to classify your objects in a certain way. So let's clean this up. Let's change class to interface, not interace, interface, okay? We'll erase the mono behavior and put what we need. So with iSelectable, let's do a public void on select, right? And we will do a public void on deselect. So there's two ways you can go about this. We can pass the game object in, which I don't think that's good, or we can also just get public game object and get game object. I like to put this in my interfaces just in case I need the game object out of it. It's very hard with an interface to get the game object otherwise. So now that we have an interface, we have this unit.cs file right here. Let's just open that up and add our interface to it. Very simple. Comma after mono behavior, iSelectable, and in order to implement it, you just push Alt-Enter, implement interface, and we have these three methods that we created. So let's just clean it up. Let's do, for this, I'm just going to make it one line. That's like an inline function. We just get out the game object that we want, right? That easy. On deselect and on select, we're going to leave blank for now because we're going to have our selection logic in there. And with that, let's create just some basic UI for this. So what we're going to do is we're going to create a canvas in the scene with an image. So you go to UI, let's create an image, and it's just going to be a blank image. We can have it here. Let's just center it in the screen. Very simple. Turn off the image, and let's rename the canvas selection canvas. You can do this multiple ways. I like to save this as a prefab and spawn it in when we need it, just to keep with the modular. I don't want to pay attention to what's going on. So I'm going to go to prefabs, and it looks like I already have one. Let's just save over it. Replace anyway. There we go. So I have my selection canvas here. We can delete it out of the scene, and that is the UI. Now let's create a selection manager that will handle the drawing of the UI on the screen. So in scripts, let's go to create, new C# script. We'll call this selection manager. All right, we're going to clean this out here. And what we're going to want is we're going to want a serialized field for our selection canvas. So let's do private game object canvas prefab. We're going to want a color for our highlight when we do the box select. So let's do a private color M select color, and I'm going to make it a new color 0, 1, 0, which is green, and then transparent on the alpha, right? So 0.3 is transparent, and that's that. Let's create a private static rect transform, which is going to control the size of our selection box. So we can call this selection box. We're going to create a private static image, and we're going to need to implement Unity engine.ui for this. So there's that. And we're going to call this mSelection image. There we go. And so now all we have to do is go to awake, private void awake, and check to see if we have a selection box. So if our selection box is equal to null, so if we don't have one, then let's create one. So we're going to do a game object canvas equals instantiate. We're going to instantiate our canvas prefab at vector3.0 and quaternion.identity and quaternion.identity. There we go. That's easy there. And so basically we want to get our image and we want to set the color, right? So let's go to canvas dot get component. Oh, we want to set our image. So mSelection image is equal to canvas dot get component in children image. And since we disabled the image, right? If you look here, there's an overload that says include inactive. That's what we want because our image is inactive by default. So let's put true there and push enter, and we're going to get our image like that. And then we're going to get our selection box. So mSelection box, which is on the same as the image, we'll do mSelection image dot get component rect transform, and there we go. We have our image in our rect transform. Now all we have to do is set the color. So let's do mSelection image dot color is equal to mSelect color. So there we go. We've initialized everything. We should have everything set up to draw the box. Now let's handle what kind of inputs we're going to need for this. So in update, we're going to check for inputs. I'm using the old input system here, but usually I use the new input system. If you're familiar with the new input system, you can easily change this however you want. But for this one, we're doing the old input system. Let's get if input dot get mouse button down. So we need when we first click, right? We also need while we're holding the button. So input dot get mouse button, and we're using left click for this. And then we also want to know when we release the mouse button. So there's input.get mouse button up. So we have all three states of the mouse button. And so in the mouse button down, what we're going to do is we're going to need to get our mouse position. That equals our start position, right? And then we're going to actually clear our current selection. Because every time we click, we're going to want a new selection. Unless you want to just completely select more and more every time. While we're holding it, we're going to update our mouse pose, right? So that's going to equal our current mouse position. Okay. And then we're going to, and that's really it. We're going to draw the box, right? So update our mouse pose and draw the selection box. And then when we get it up, we're just going to take what we have and select units within the box. So there's our steps on how to get this done. Should not be very hard. Let's just get this going. So first, let's create two vector 2s. So private vector 2, we'll do mStart pose, which is our mouse start position, and mEnd pose, which is our current mouse position and where we end. There's that. So what we did right here, we can say mStart pose is equal to input.mouse position. And here we can do, when we update, mEnd pose is equal to input.mouse position. So we've got, we're already done. We're already almost done, right? All right. And so now we're actually going to clear our current selection, but we don't have a selection yet. So what we're going to do is create a private list of our iSelectables, right? That's why we created it. We're selecting these, and we can just call this mSelected, create a new list iSelectable, and that's easy. And so basically what we're going to do is we're going to clear our current selection. So let's create a function called clear selection. There we go. And under here, let's do private void clear selection. And all we're going to need to do is, we're going to do mSelected.clear, but before we do that, it looks like we're inside of the update function. Let's get out of that. There we go. So we're going to clear it, but before we clear it, we're actually going to have to deselect, right? That's why we had this on deselect event. We're going to have to deselect. So for each var s, or selected, in m selected. We're just going to do s dot on deselect, and now we clear. And what I'd like to do is, to keep this modular and keep everything going, we're going to create a static event, right? So we're going to create a static event that says that our selected units has changed. So let's do a public static event action, which takes in a list of I selectable, and we'll say selection changed. I like to put an S in front of this, but yeah, basically this, selection changed. So here, once we do that, we just call S selection changed, question mark, dot invoke, and we pass in our selected. And now whoever subscribed to this will get, the new selection box. Very simple, very easy, and we've cleared our selection. Now, before we can really see anything happen, we're going to have to draw the selection box. So now let's draw the selection box. First, let's create a function called draw selection. Okay. And what do we need to do? So first create it. So draw selection. Okay. And we're going to turn on the box / image, whatever it is, right? We want basically the width and the height. Then we're going to set the size of the box. We're going to find the center and position the box there, right? So that's how you draw a selection box. So let's go here. So we have our selection box up here. So we'll say if m selection box dot game object dot active self. So if it is active, but we can just do the opposite. So if it's not active, then let's activate it. So we'll do m selection box dot game object dot set active true. So now we're turning on the box. Let's get the width and the height, which is actually really simple. Width is on the x-axis, height is on the y-axis. And so we have our two starts and end pose. So we'll do float width is equal to m end pose dot x minus m start pose dot x, and the height is equal to our end pose dot y minus our start pose dot y. And that is the width and the height, which means we get the size, right? But this could be negative, right? And so with a size, we want it to actually be positive. So what we can do is we can say vector2 size is equal to new vector2 width and height, but we want the absolute value. So we'll say mathf.abs width and mathf.abs height, right? So now we have the size, and so let's just set the size. So we have our m selection box, which is our rect transform. In order to set the size, you set the size delta, and we set the size delta equal to the size. Very easy, very simple. And now, so once we have that, we need to get the center, and so we can center this box and set the size based on that and update that. Let's find the center. So the center will be the start position, and then we have half the width and half the height, which will bring us directly right into the middle. So very simple. Let's do vector3 center. Well, it's a vector2, right? Vector2 center is equal to m start pose plus basically size divided by 2, right? Because it's the width and the height. Oh, but the thing about size is it's positive. We want it negative 2, right? So let's just do a new one. New vector2. Let's do width divided by 2 and height divided by 2. That way we keep our negative values and we actually find the real center that we want. And then all we have to do is set the position of our box. So m selection box dot position is equal to center. And with that, we should be able to draw a selection box, right? So here we go. I must have spelled it wrong. Spelled it wrong here. So let's spell it right. I like to draw selection. There we go. All right. So now we have draw selection. And let's test it out. But before we do, we have to add our selection manager. So let's go here, create empty selection manager. Let's pop that in here. And we need our canvas prefab. There it is. This is the color that it's going to be. And with that, let's test it. So that's really it. That's how we're going to draw this box and draw everything we need to draw. And with that, let's move on to the next element, which is converting this box into something that is actually on the ground. All right, so for this part, we're going to use onDrawGUI to visualize it, and then we're going to transfer it all into a function that will actually draw the box and do the selecting. Here, what I want to do is I don't like the fact that it was staying on the screen, so here we'll do a, select units, okay? And we'll just create that little function really quick. So it's private void select units. And with that, let's just turn off the selection box. So m selection box dot set active equals false. And that way it's going to turn off. But to visualize everything for the actual calculations, let's go into private void on draw gizmos. There we go. Let's set our gizmos color to red for now. It's perfect. And so if we are holding our mouse button down, we're going to be drawing these gizmos. And the first thing we want to do is we want to get the corners of our box and raycast into world space, right? That's the first easy thing, escape. Okay, so in order to do that, we can actually create a little function. Let's create a little function. Let's call it selection corners world space. And we're actually going to release a vector2. So or vector3 because it's world space. So we're going to do vector3 selection corners world space. There it is. And so let's say vector3 array corners is equal to selection corners world space. Perfect. And so what we want to do is we want to get our start position and end pose, and then calculate the other 2 points, right? So we need the other 2 points, so we have a full box. Then we're going to raycast from all those points onto the ground, and that's going to be our world space corners, right? So let's create to start off, let's create a new vector3 array. We'll call this corners world space, and it's new vector3, and there's 4 points, so we'll do 4, length of 4. All right, and so we have our start pose and our end pose, so let's get the other 2 points. We're going to do a vector2. Point 2 is equal to basically a new vector2. It's going to be the start pose x and the end pose y, right? Because we're drawing a square. And then vector2 point 3 is going to be the opposite. So new vector2, and we're going to do the end pose x and the start pose y, right? So now we have our 4 points. Very simple. We're just going to loop through them. So what we can do is create like a little array. So let's do a vector2 array of corners, and we'll make a new vector2 4. And basically it will be our start point, point 2, point 3, and our end point, right? So there we go. Let's loop through that. So we're going to raycast from those points. So let's do a 4 int I equals 0. I is less than 4, I plus plus, and we want to do a raycast, right? So physics.raycast, we're going to do a camera.main, screen point array, and we're going to take our corners. So each one of our corners, corner I, we're going to want to out a raycast hit. So let's create a raycast hit array that is the same length, and we'll call this hits. So it's equal to 4, and there we go. It's a length of 4, and so we can put this out as hits I, and we can put a distance of 1,000. That's fine. All right, and so there we go. We've got our hits. If it's valid, it will come out as a great point. And so what we can do is get our corners world space I, and that will equal our hits I dot point, and that will translate. So each one of these positions will translate to the exact same index, but in world space. And once that's done, we can really just return this world space vector3 array, and we should have them. And just to prove it, let's test it out in the on-draw gizmos. So for each var c in corners, let's do a gizmos dot draw wire sphere. We'll say c and a radius of 0.5. All right, so we have that, and let's test it out. You can turn on gizmos if you want to do that. So click gizmos, or you can look in the game view. And as we draw it, you see it. And if we look in the actual scene view, you'll see it better because it kind of glitches out the top half of the screen on the game view. But you can see where we're drawing, our gizmos are there, Let me get you a better angle here so it's more similar to what we're looking at. But as we're clicking, we have our points translated directly onto the screen, right? So that's good, and that's all. And I wish that this was the end, but I'll show you what happens if you were just to take these and, draw a box without applying any rotation. So we'll call this what not to do. So here we have our 4 corners. And so in order to draw a sphere, in order to draw a box, we just need the center. So let's say vector 3 center, and that is equal to 0. And basically the center would be the average of the corners. So let's call center plus equals C. And then at the end of that, center divided by equals 4. So that's our center. So what we can do is we can do a gizmos dot draw wire cube, and we'll say our center, and the size would be, well, it'd be width and height, right? So the width would be the distance between the corners of the x, and the length would be the distance between the corners of the x and the y, right? So let's say vector 3 dot distance, and we'll say corners 0, which is our start pose, and corners 1, which is 0.1. They have the same x. And then float length is equal to vector 3 dot distance of corners 0, which is our start, and then corners 2, which has the same y. Okay? So then here we do, for height, we'll do a new vector 3, which is going to be our size. It's going to be width, 1, and length, right? So x and z. And with that, you'd assume that we would have some kind of, square that we want, right? Basically, we're drawing these, but what I can show you is the way the square draws is kind of rotation agnostic. It will not rotate, right? So it looks right, but in certain positions, you're not going to get the same area that you want to, select. So here, if you look correctly, we're over top of the cacti in some areas, and we're not quite reaching the cacti in other areas, whereas our box is actually fully covering it. So it may seem like a small thing, but I think, it's worth the little extra effort to actually try it. And you can see here on this game screen, actually, it doesn't align at all. So what we want to do is change the rotation of this box to have it align. And that is where a little bit of the difficult part comes in. So let's get the rotation correct. All right, so in order to get the rotation correct, we need to have some sort of standardized orientation of the box, right? So if we're here and we have our, box, well, our start point is now in the top left. But here, our start point is in the bottom right. So what we want to do is make sure that we always count our points in the same order. So what we're going to do is we're going to start from bottom left, top right, bottom right, and that way we can orient them in the right way to calculate the rotation effectively. So in order to orient the points, there's a difficult way, but there's also really just like kind of an easy-ish way. We're going to create a new private vector 3 orient points, and we're going to take in our corners. And so all this is going to do is take these corners and orient them in the way that we want. We want bottom left, top right, and bottom right. That's how we want them to end up, right? So let's create a new vector 3 array. We'll call this oriented. It is also going to be a length of 4, so 4, and it's just going to be an empty one. And so now we're basically going to check. So it's really just kind of calculating what's going on. So if our start pose dot x is less than our end pose dot x, and our start pose dot y is less than our end pose dot y, well, then we know that the bottom left will be our start pose. So we'll do oriented equals start pose. We also know that our end pose will be exactly the opposite of it. So if our start pose is bottom left, then our end pose will have to be the top right. So what's the top right is the third one. So we'll say oriented 2, which is the third one, is equal to end pose, right? And that's top right. Now to fill in the other ones, it's very simple. our, if we're bottom left, then we want the same one with the same x. So oriented 0 is equal to 0.2, which is corners 1, right? And we can use the corners array for all of this, right? So we can do corners 0, which remember was the start pose, and corners 3, which was the end pose. And so if that really just leaves one more, right? Which is corners 2 for oriented 3. This is oriented 1, 2, 3, right? So we have bottom left, top right, and bottom right. That easy. And so we can just continue through these other ways. So let's do an else if. And we say if our start pose dot x is less than our end pose dot x, but our start pose dot y is greater than or equal to our end pose dot y. Oh, come on. Autocorrect, you don't know what I want. All right, there we go. So if that's the case, then we know that our start pose is going to be on the top left, right? So let's say top left is 1, so oriented 1 is equal to our start pose, which is corner 0. Okay, so that's top left. And the opposite would be bottom right, right? So bottom right is the same thing as oriented 3. So oriented 3 is bottom right, so that's going to be corners 3. Okay, and so that's basically that. So now we need to basically figure out the other ones, right? So we're going bottom right. And so here, let's do bottom left. So this is oriented 0. It's going to have the same x, which is going to mean that this is corners 1, right? So same x is corners 1, same y is corners 2. So say bottom left, the same way we want, and top right. So oriented 2 is equal to corners dot 2. All right. We just have a few more of these to do and to get them right. So let's just get them, the same kind of logic. So else if we have both of them greater. So if our start pose dot x is greater than or equal to our end pose dot x, and our start pose dot y is greater than or equal to our end pose dot y, then we know we have we're oriented 0, right? So we're starting our bottom right is going to be, so our bottom left is going to be our end point, because we're going the exact opposite of the first one, right? So our bottom left is going to be the end point, so corners 3 is our end point. And then so that means bottom right, and so that means top right is going to be our start point, so oriented top right is number 3, or number 2, so oriented 2 is equal to corner 0, and just fill out the rest of these the same way. So that means this one is going to be corners 2, and this one is going to be corners 1. And so now we're on the final one, and this literally just took out some, it took some visualization and math and just drawing it out. Actually, not really much math, just drawing it out. So we have our bottom left, and the final one where that means that our x is greater, but our y is less. So we have oriented 0 is equal to corners 2. Oriented 1 is equal to, I can't spell, is equal to corners 3. Oriented 2 is equal to corners 1. And oriented 3 is equal to corners 0. And so now we just return our oriented array, and we've got these all in the right direction and orientation, allowing us to calculate the rotation, which is actually probably the simplest code but the most complicated concept. So let's just go in here and let's save our oriented points. So basically let's delete, we had our fun with this, but let's delete this and get this done the right way. So we have our vector 3 array of oriented points. So we'll just call this oriented is equal to orient points and corners. Perfect. And so now we need to calculate the rotation. So quaternion rotation is equal to calculate rotation, and we're gonna put in our oriented points. Oriented. I can never spell this. All right. And I wish that it was just this easy, but we have to make the function. So let's go in, private quaternion, calculate rotation. Yes, 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 okay. And that takes in a vector3 array of our oriented points. And we will we need to get our, we're doing matrix multiplication in order to find out the proper rotation. So we're going to multiply our x direction by our y direction and our z direction, which is our forward, get all that, put them into a rotation matrix, and luckily it will do all the math for us and output what we need. So let's get our x. So vector3.x. So our x direction will be our oriented points 3, which is our bottom right? And minus our oriented point 0, which is our bottom, point 0, which is our bottom left. And we're just going to get normalized. So that's just the direction. Okay. Our y is going to be this very similar thing. We just want the y, right? So it will be our oriented points 1, which is the top left, minus our oriented point 0, which is our bottom left. If you can see the pattern in here, we're just getting the direction. So we have that. And now our z, our forward, is going to be the cross product, which is kind of a perpendicular line between two directions. So we're going to do a vector3 dot cross between our x and our y, and that will give us our forward direction. And that's really all we need to calculate the rotation. So now for the rotation, we're going to do a matrix 4x4, which is our rotation matrix. New matrix 4x4. I don't know if you've ever done one of these, but you just take 4 vector 4s, or you can do vector 3s. And so you do x, y, and z, and then a new vector 4, which is just kind of the basic rotation, which is 0, 0, 0, and then 1 for our w, right? So that's how quaternions work. And so now we can just return rotation matrix dot rotation, and that will give us the proper rotation for what we want. So out here, now we have our correct rotation. And so now that that's done, let's just get our distance back. So let's do float width is equal to vector3 dot distance, and we'll just say, corners 0. Well, let's get our oriented points. So oriented 0 and oriented 3, which is, top left, bottom right. And we're going to get our height, which is vector 3. Well, it's a length, right? It's the distance between oriented 0 and oriented 1. Right? So we have our width and height, or width and length, I guess you call it. Okay? And then we just do our, let's call this a size. Let's do vector3 size is equal to new vector3. We'll do a width, length, and 1. And that is because with this rotation, it messes with everything really weird. All right, we're going to now put all this stuff into something called a matrix for the gizmos. So we'll do gizmos.matrix, and that will say matrix 4x4 TRS, which is translation, rotation, and scale. We'll put in our center, our rotation, and our size, and we will draw our gizmos.draw wire cube, and we'll put in center is going to be vector3.0 since we set it here, and vector3.1 for the size since we set it in the TRS. And so now let's see how it looks when we draw it. And so when we go, we've actually gotten a lot more of the exact points that we want, right? It looks like it's exactly in the right spot, and it's going to highlight what we need, when we need it, and where we're going to go. But if you see, sometimes the rotation and everything is off. And so actually, there's something you have to do to make it a little bit more fine-tuned. Instead of doing float width, length, and distance like that, we're going to get a width vector and a height vector, and we're going to mix them together in order to get the correct size. So here, we're going down, and we're going to do this. So vector3 width vector is basically going to take our oriented 2, which is our top right, minus our oriented 1, which is our top left, right? And then we're going to add that to our oriented 3, which is our bottom right, minus our oriented 0, which is our bottom left. We're going to divide that by 2, which gives us our vector. And we're going to do a very similar thing for the height one. So we'll call this the height or the length vector. It's okay. We'll call it the height vector. We're going to say oriented 1 minus oriented 0, which is up and down. And then oriented 2 minus oriented 3, which is up, top and bottom, right? So top and bottom, we're dividing them by 2. And so that gives us our new size. And so now we can do a vector 3 dot size for our matrix. And we're going to say new vector 3. We're going to take in our width vector dot magnitude. We're going to take in our height vector dot magnitude. And then we're going to put in 1 for the size. You can always customize the size here. This is going to basically say how tall do you want your box to be. And let's show you what it looks like now. And so now when you look at it, we've actually gotten to the exact point where everything will be aligned and put in. Anything you select will be selected, and it's perfect. You're going to get the rotation that you need and whatever you want. So now that we have it drawn on gizmos, the final part is to actually make it select the units. Luckily, we've done all the logic in here, so we can just copy this, go to select units, paste that in, and just kind of clean up everything, right? So we don't need to draw the wire sphere. We still need the center. We still need to orient the points, calculate the rotation. We don't need to get the gizmos matrix or any of that. But what we do need to do is get the colliders, right? So let's do a collider array, call colliders, and we'll say physics.overlap box, center, size divided by 2, rotation, and we're going to need a layer mask, so we'll create a selectable layer. So we'll say selectable layer, and let's go up there and create that. So we'll go up here, we'll create a serialized field, private layer mask, selectable layer, and we'll create that and set that in a second. But that's basically like that. And so all we need to do is, once we have these colliders, we say for each call in colliders, let us see if they're selectable. So we'll do an selectable is equal to col.getComponent selectable, right? So we're seeing if they're selectable. Then we're going to say if selectable is equal to null. Let's just continue. We don't need to worry about it. Then we're going to say selectable dot onSelect. So we're going to call our onSelect function. We're going to mSelected.add our new selectable. And then at the end of all of that, we're going to say our event, which changed the selection, which changed our selected objects. So we'll do mSelected is equal to that. And there's all that. The final piece of the puzzle here, so this is going to select everything, but it won't reflect because we need to implement our onSelect and onDeselect. So we can go in here and let's create a public bool is selected. Let's make it a get private set. So it's only set in here. And let's onSelect, we're going to say is selected is equal to true. And onDeselect is selected is equal to false. Right? And we also have a visual that I created, so let's just get a reference to that. So we'll do a serialized field, private game object, selection ring. All right, and we'll just set that equal to false when it's word on deselect. So dot set active false, and on select we'll set it equal to true. Right, and there's that. And now I don't want to move them unless we're selecting them, right? So now we can go in here, and where we're selecting them, we say if we are selected, then we move. If we aren't selected, then we don't move, right? That should be that easy. And so let's test it. I think what we want is first we need to set our selectable layer. So let's create a new layer. Let's call it selectables. That's fine. Pop our soldier on that layer. Yes, we'll change the children. And on the selection manager, let's select that layer as the selectable layer. And so we set the layer, we set that all, but now we need to set the selection ring. So let's set the selection ring. Oh, well, I've already connected it to him. So let's go here into our soldier. Apply that selection ring right there. Let's duplicate our soldier like 100 times or however many times you want. I'm going to put it in maximize and we can see how it all works out. So we select our guys And there we go. We can select half of them. The other half can go over here. We can select a few. We can even select one if we want. Right? It doesn't have to select a bunch. It's just drawing a little box, so even if the box is small, we can select all of these guys and do whatever we need. It's pretty crazy. So I hope this tutorial enlightened you in the difficulty of creating a system that does exactly what you want it to. I'm sure there are room for improvements in this system, but the point it's at right now is very good for a game you want to release, a prototype, and it's super modular, so you can just put it right in. You can get the finished product on my GitHub as well. If you don't want to go through the tutorial, that's cool too. If you like this video, please leave a like, subscribe if you want more content like this, and comment below if you want something else. If you didn't like this tutorial, if you want me to go further on something, or whatever kinds of features you want, just let me know and we'll get it done. Thanks.